Hey everyone, and welcome. Today, we're going to jump into one of the most important and high-scoring chapters in your Class 10 math syllabus, polynomials. Trust me, getting these concepts down is absolutely key for your exams and for all the math you're going to see later on. So let's get right into it and master these basics together.
So to get our heads in the game, let's start with a really simple idea you already know. Imagine a square. We don't know how long its sides are, so in algebra, what do? We just call it x. Now, if you wanted to find its perimeter, you just add up all four sides, right? That gives us 4 times x, or 4x. And its area? Well, that's just side times side, or x squared. These little expressions, 4x and x squared, are actually perfect, simple examples of the polynomials we're about to explore.
Okay, so that leads us to the big question. We've seen things like 4x and x squared, but what actually makes something a polynomial? Let's build a really strong foundation with a single, most important definition. If you remember just one thing from today, make it this rule.
And here it is. A polynomial is just an algebraic expression where the powers, the exponents of the variable, are only whole numbers. That means the powers can be 0, 1, 2, 3, and so on up. The key thing to burn into your memory is this: no fractions and no negative numbers are allowed in the power. It's really that straightforward.
Let's make this totally clear with a few examples. This table shows the rule in action. On the left, you've got your valid polynomials. See the powers? 3, 2, 1, all good. They're whole numbers. But now look really closely at the right side. The expression 1 over x is really just x to the power of minus 1. Since negative 1 is a negative number, nope, it's not a polynomial. Same thing for the square root of x. That's the same as x to the power of 1/2. Again, it's a fraction, so it's out. This is a super common trap in exams, so make sure you really get this difference.
So every polynomial is made up of a couple of key parts. First, we have terms. These are just the individual chunks of the expression that are being added or subtracted. So in this example here, negative x cubed, 4x squared, 7x, and negative 2 are the 4 terms. And that number sitting in front of the variable in each term, that's called the coefficient. So for 4x squared, the coefficient is 4. And for negative x cubed, the coefficient is minus 1. Simple, right?
All right, now that we know what a polynomial is, let's figure out how we classify them. You can think of it like giving each polynomial a name based on its features. The first and easiest way is just by counting how many terms it has. This table lays it out nice and clear. If a polynomial has just one term, like 5x cubed, we call it a monomial. Makes sense? Mono means 1. If it has 2 terms like x squared minus x, we call it a binomial, because bi means 2. And you guessed it, if it has 3 terms like y to the 4th plus y plus 5, it's a trinomial, since tri means 3. Mono, bi, tri. 1, 2, 3. Super easy to remember.
Now, counting terms is one way to name these, but there's another way that's even more important. It's based on something called its degree. You'll want to pay close attention here, because understanding the degree is absolutely crucial for your exams.
So, what on earth is the degree? It's literally just the highest power of the variable in the whole polynomial. That's all you have to do. Scan all the exponents and find the biggest one. That's it. That one number is the degree.
And based on that degree, we have some really important special names. A polynomial of degree 1, where the highest power of x is just 1, is called a linear polynomial. If the highest power is 2, like you see in ax squared plus bx plus c, we call that a quadratic polynomial. And if the highest power is 3, it's a cubic polynomial. You are going to be seeing these 3, linear, quadratic, and cubic, all the time.
Okay, theory is great, but we all know that practice is where we really learn. So let's walk through an example step by step to make sure you've totally got this. Don't worry, we'll do it together. You've got this.
All right, here's our polynomial. 2 minus y squared minus y cubed plus 2y to the 8th. Our job is to find its degree. So what's the first step? We're just going to look at each term one by one and check the power of the variable y. Okay, let's scan those exponents. The term negative y squared has a power of 2. The next one, negative y cubed, has a power of 3. And that last one, 2y to the 8th, has a power of 8. So between 2, 3, and 8, which one is the highest? Well, it's 8, of course. So that last term is the one we need to focus on.
So the term with the highest power is 2y to the 8th. And the exponent on the variable in this term is 8. That's the number we've been looking for.
And there we have it, our final answer. The degree of this polynomial is 8.
See? It's just about finding that one biggest exponent. Not so tough, right? Well done! All right, great job, everyone. Before we wrap up, let's do a super quick recap of the most important points from today. Think of this as your cheat sheet, the things you absolutely have to remember for your exams.
So, to sum it all up, first, the golden rule. A polynomial must have whole number exponents. No fractions, no negatives. Got it? Second, the degree is simply the single highest exponent you can find. And finally, don't get the names mixed up. Monomial, binomial, and trinomial tell you about the number of terms, while linear, quadratic, and cubic tell you about the degree.
And here is my most important exam tip for you today. You have to know that examiners love to set traps with this rule. So be on high alert if you see a variable hiding in the denominator, like 2 over y, or under a square root, like root t. As we just learned, these are not polynomials because their exponents are actually negative or fractions. It's such a common mistake, so whatever you do, don't fall for it. I'll leave you with a little question to chew on. We know how to find the degree when there's an x or a y, but what about a constant polynomial, like just the number 7? What would its degree be? Think about the definition of exponents we talked about today. We'll explore that and a lot more in our next explainer. Keep practicing, and I'll see you then.